Wow, beautiful video. Hello everyone. My name is Vadim Briliantov. I'm a technical lead of Koog in JetBrains. And thanks for joining my session. I really hope you're going to enjoy it. At least hope you are not going to fall asleep. Please don't. Because we will be building fault-tolerant AI agents with Koog framework by JetBrains. Just a quick checkup. Please raise your hand if you already know about Koog and you knew it before this conference. OK, great. If you've seen my other talks, I used to start my presentations with the phrase, let's Koog some AI together. But today is a different day, OK? And I'm damn hungry. So why wouldn't we cook a sandwich? I know that there is a tradition to start deeply technical talks with a good story. I'm sorry, I don't have any, only the bad ones. So let me tell you my bad story. First, I have to probably introduce the characters. That dude, it's me, it's myself, but younger and with much more hair on my head, as you may see. And it's been like several years ago, and I've been working on a project called Ktor. Do you know Ktor? Who knows Ktor? All right. So if you're not aware, Ktor is a direct competitor of Spring Framework, but in Kotlin. And of course, I had a manager. His name is Hadi. Awesome guy. Like, I love his jokes. He's like really funny. One of the best people I've worked with. And the only reason for me to attend a daily meeting would be listening to his jokes. Like, really cool guy. But unfortunately, at some point, I became bored with what I was doing, and I switched to doing something else, also inside JetBrains. I decided to do some like real backend development, not the frameworks, but like the real hands-on. I was like really happy with that. But as you may notice, my manager, he wasn't. He was like really upset, like really angry at me for me leaving. But I still did that. And then a few months later, I met my ex-manager and my now also ex-CEO in the JetBrains cafeteria. And by the way, in JetBrains, we have amazing cafeteria, like really great food there, and for free. So the only reason for me to like come to the office every day was because of the great cafeteria and free food. I'm not doing it anymore. I met my ex-manager chatting and laughing with my ex-CEO. And I joined them. And for me, it was like the first time I ever saw the CEO in person. So I was expecting my ex-manager to introduce me to my ex-CEO. And he did. He pointed at me, and he shouted, "Look at this guy. His name is Vadim. Remember him? He's a traitor. He betrayed me. He betrayed my project. And he left Ktor to do something else, but also inside JetBrains. And then he leaves. And then he comes back, but with a sandwich. And he gives me this sandwich and tells, like, Vadim, please, take this sandwich and remember it well. Because this is the last thing that you ever get from me again. Ever. And oh well, this sandwich, let me put it larger on the screen. It was like this one. This sandwich, it was so damn good, so delicious, amazing sandwich, one of the best I've tried. But for me, it was also the last one with Ktor. And for that reason, today I'm going to use Spring. And remember, like at the beginning, I promised it's going to be with some... by the way, Spring Sandwich, that's the name of the app that we're going to be building today. So remember, I promised that it's going to be with some, this buzzword, how to say that, remember, AI, right? The Spring Sandwich with AI. And we're going to cook the whole AI thing out of it using the Koog framework by JetBrains. It's an open source framework that you can use to build any AI agents for any application of yours for free, because it's open source. And you can make them scalable, fault-tolerant, which is obviously the main goal of this talk, and enterprise-ready, because it provides out-of-the-box integrations with your enterprise stack. So it runs on the JVM. It has integration with Spring and also with Ktor. But remember, we all love sandwiches, right? So today we're going to use Spring. And one of the main things that I would tell about Koog framework before we jump right into the hands-on part is that it's battle-tested on our actual products of JetBrains. So it's used in our products that in our AI agents that we're actually building in the company. It's powering our internal development, and it solves lots of problems that we actually faced at scale when delivering something for production. And now you can also use it. So let's build something together. So the app that we're going to be building, it's going to be some like e-commerce backend with some like e-commerce delivery, blah, blah, blah with that. Who knows what's e-commerce? I don't. But I think it's something that can like deliver any products right to your like home, and you can like order them online, including these beautiful sandwiches that you may see on the picture, right? So to build this application, we're going to need our first ingredient, and that's going to be your Spring application. Do you already have a Spring application? Who does? OK, quite a lot of people, much more than those who know about Koog. I hope that might change. So if you don't have a Spring application, let's briefly build one. So I'm going to define a REST controller that will control all the API requests for the app. You might have some like services injected from Spring Framework. And let's add another one at the end, which is something new. It's called like Koog Agent Service. We will build it ourselves during this session. And it will do some AI magic for us. Yeah? And now let's think of some AI agent application for this e-commerce website. Do you have any ideas? Like how to apply AI, like what to do with like delivery system, like with AI? Any ideas? You would never guess. Like I have amazing idea. Like you would never guess. Like it's so unique. You never seen this application of AI agents. Trust me. Are you ready? Chat support. Yeah. So we're going to build a chat support, and users would launch a support agent via the post/support endpoint. Of course, they need the principal for authentication. And they will provide us with a support request. It's not important what it is, just like some request. And we will reply with the agent ID. And to implement this endpoint, we would need to like launch the agent, get the ID, and provide it for the user so that they can track its progress. Remember, agents are like long-running operations. All right? But how? How are we going to build our first AI agent with Koog? Well, for that, we need our second ingredient. We need to add it to our app. It would be AI agents from Koog Framework. So what are AI agents? In our vision, agents consist of three important components. First of them is environment. It's like some functionality that the agent might use. Then the agent orchestration logic itself. And finally, the connection to language models, one or many. From the user's perspective, it looks very primitive. User will send an input, wait for some time, and get the final result. As simple as that. But under the hood, the whole process will happen. The agent will send LLM requests to the model and get back the LLM responses, which are always either assistant messages, like plain text, or tool calls. If LLM decides to call a tool, the agent logic will call a tool from the environment and get back the tool result, and continue this process until the user's problem is solved. Inside the agent, there will be like some agent strategy. It's like the algorithm that powers the agent. And what is environment? Do you know what is environment in our system? Any ideas? Well, context. Spring context? No. It's your application. It's your Spring application that you are building right now. It's going to be our environment for the agent. And now let me define the picture on the left with a code using Koog Framework on the right. I'm going to use Kotlin because I love Kotlin, but you can also do it in Java. So I define AI agent. First, I connect it to tools from your application. For that, I use tool registry. Inside of that, I register the tools from the app. I will show it later. Then I'm going to define the strategy. Again, I'm going to show you later how to do that. That will power the agent's logic. Then I will configure the agent, like what is the system prompt, what task is it solving. I will provide the model, for example, like GPT-4o or something else, and other parameters like maximum iterations and other things. And finally, I would need a connection to the actual model provider, like OpenAI. So again, the simplest agent example looks like this. If you are building a banking application, all you need to write, AI agent, provide the banking tools, define the prompt, like you are banking assistant, define the model that you want to use, like GPT-4o. No idea why, like I just love this model. And connect to OpenAI with a key. That's it, like 1, 2, 3, without brackets, 5 lines of code, and instantly your banking application will become agentic. That's it. Super simple startup with Koog. And you even don't need a strategy, because Koog already knows some out-of-the-box default strategy that will power your agent. You can define it later if you want to customize something. So how would you connect to the actual functionality from your Spring app? For that, we need our third ingredient, which is tools from your application. Tools are essentially any function in your existing code base. Let me give you an example. In our delivery system, like for support bot, we would need some like emailing functionality. So let's define a function send email, which will have recipient email, email text, and well, return some string, whatever. And how to make it a tool, how to make it available for the LLM. Just call it a tool. Very simple. But do you have any idea, like what does it return? What is the meaning of a recipient email? Like what is the format and etc.? Well, I don't know. Maybe you're also struggling. Imagine like you are humans. You are much smarter than LLMs. LLMs will not know it either. So you need to explain what is the meaning of the function, what is the meaning of each argument. And then it will behave much better. So we just defined our first tool for the agent, send email. I'm not showing you the code. I believe you all can program something. But we're going to need much more. Let's add more tools. Let's define a class, user tools, that will have an injected parameter, user ID. That's the ID of the user. And it's important because for the tools, LLM will imagine and like construct the parameters by themselves. But user ID, it's very important. You don't want an LLM to work with another user. You only want it to like work with the user currently authenticated, right? So for that reason, we will inject the fixed user ID from the request, and we will inherit the toolset marker interface from Koog. And inside, we can define any tools. Again, read user orders, read user account. But that's boring. That's not interesting. We want our agent not to be just like a typical chat support bot. We want it to be like actually interactive, to like proactively help the user with the problem. So let's define more tools. Issue refund. The agent will issue a refund. And make another order. And we can define even more tools, like order tools, another tool set. It will be able to like contact the carrier for the delivery and update the address. And you can add something else. So to summarize, you can add like conversation tools, user account updates, order modifications, many other tools. And LLM will be able to call each of them, depending on the problem, to fix the situation with the user's order. So essentially, you are giving all the power to the LLM. It will rule the whole system. It will be the brain. Is that really what you want? Any problems that you might see here? Well, the models, they become more smart, and they are improving. But even if it works 9 out of 10 times, or 99% of times, you should never trust these randomly working guessing machines. LLM will essentially, like at the end of the day, will break your system and mess things up. But the question is, whom should you trust in the age of AI? If we should not fully trust LLMs or any other magical AI algorithms, whom should you trust? Well, the only entity on Earth you should trust is yourself. Only the code that you programmed is what you can rely on, right? And to do that, we would add up our fourth ingredient, which is a custom strategy for your task. By the way, this is how the default strategy looks if you draw it. So like you start the agent, then you ask LLM what to do, then you call a tool. If LLM wants to do so, then you send the tool result back to the LLM, and then it continues this loop until the LLM decides to finish. That works, but the problem is that you are giving all the tools available at once. And remember this picture before, LLM will mess up your system. So let's define the custom strategy for our problem. In Koog, you define all the strategies. I mean, there are multiple ways of doing that, but the most advanced way is to define it as a graph. So it's like a state machine, and each node of the state machine, each step of our algorithm, is essentially a node that has some input of some data type and some output. And you can combine one node after each other if they are type compatible. So we start our agent, and we get a string input from the user. Then the next step that I would do here is identify the problem. Let's understand, together with the user, and by also using the database, what is the order, what is the problem, and many other details. And for this step, let's only give the reading tools and conversation tools to talk to the user. So the goal of this step to only identify the problem and produce the order support request. That's a data type. You can define it, data class in Kotlin or in Java. You mark it as serializable, and you also provide LLM description for whatever fields you need LLM to fill in. So it's like a form filling. You ask the LLM to fill in the form, and after it only finishes the process only after each field is resolved. It knows what to do. It doesn't finish beforehand. It's not like just working with plain string and text like you would do in Python, right? So you produce the order support request. You just declare what data type you want. And after you identify the problem, let's actually fix that. That's another step of the algorithm. And I would provide all the modification tools, like order updates, user account updates, everything else. And it will produce the order update summary. It will take the support request, the data type, and produce the order support summary with any details you feel reasonable, right? So far we have identified the problem, and we fixed that. Are we done yet? Is there anything missing? What do you think? Well, remember this picture again. LLM will eventually mess up things. You shouldn't trust it. You should verify. So let's add up verification step here. Let's add the order update summary, verification step that will take the order update summary and produce a class called critic result from order update summary. It will have the answer to the question whether it's successful solution or not, the textual feedback so that we can adjust the solution, and the initial order update summary. All right? And for this step, we're going to provide only the reading tools and observation tools so that LLM can check whether the problem is actually solved or not. And then we can, if the problem is successfully solved, we can go to a finish step with the order update summary. Or if it's not successful, we're going to provide the textual feedback to the adjustment step, which is basically similar to fixing a problem, but with a feedback. And then, after we have adjusted what we have to do, we have to verify it again, and re-verify it again, and again, and again, until it's successful. And that strategy is much more predictable and much more resilient. And you can add any custom steps, any custom action, like you can program the code what you want to be executed. And that is the system that is trustful. Why? Because you just programmed it, right? Oh, sorry, we didn't program it, but let's do so. Let's define the strategy with Koog. How to do that? It's super easy. That's all the component. You don't have to program inner loops and everything else. Just use the out-of-the-box components from Koog framework. Identifying the problem, the first step, super easy. You just use subgraph with task. You declare which input type and output type you want. You define the tools, And you provide the question, like what task you're solving. And it's, of course, like very simple question. I hate prompt engineering. I prefer like writing simple questions, but you can refine it. The next step, very similar. I use same components, some graph with task, different data types, different tools, different question. But I also specify a different model, and I change the model for the step on the fly. I prefer Sonnet 4 or any other Sonnet because during this step, we're going to do a lot of tool calling and modifications, which need to be like very precise. And Sonnet tends to be much better with tool calling. And the next step is like verifying the solution. There is also a pre-built component for that in Koog. It's called subgraph with verification. And it works with order update summary. It takes one, and it produces a critic result. Same thing, you provide the tools. You change the model. I prefer using some like reasoning models like O3, because we need to reason about the results. And I define the task as a lambda, like which takes the input and produces the text. And the final step is adjustment. Same thing as before. Subgraph with task, different tools, different model, again Sonnet, and the task. That's it. And of course, the data types that you work with. So what's left? You only have to glue all of that together with edges. So this is the Kotlin DSL. So I define like from which node to which other node I can go. I can also define conditions like when, in which situation I go to some other node, which are basically any code that you can program. Everything is type safe. And if you need to change the type when going through the edge, there is a transformation lambda that you can also provide. That's it. I'm not going to like dive too deep in this code. You will see the example at the end of the presentation. But the great thing is that we just built the strategy with just a little amount of code. And the beautiful thing of that is you never think about the context here. Everything that you care about is the input, the output, tools, and that's it, and the task. Of course, right? So the framework takes care about all the messages and history and adding up tool calls, tool replies to the conversation. All of that happens out of the box, under the hood. And another interesting thing is that the steps, they are not independent agents. They all share the same message history. They all have the same context. And we tried this approach in JetBrains for our agents, and this approach works much better than like stacking one independent agent after another. And another thing that is cool is that it works even when you switch the LLMs on the fly, which we just did, right? I'm not really aware of too many frameworks that allow you to do this out of the box, but Koog does. So we just programmed the endpoint that runs the agent. We connected it with our tools. We built a resilient strategy. Do you see any issues now? Well, let's think about that. Remember that LLMs they take a lot of time. Agents are long-running processes. And we have user communication via emails, right? It takes even more time. I would usually first eat up my sandwich and then answer the email. So you can wait for hours, right? So the system is running, and it's running for a long time. And suddenly something happens. Your application crashes. That's normal. Or if you're using AWS EC2 Spot instances for obvious cost optimization reasons, they are cool, but AWS can interrupt the process, kill your running agent, and restart it on some other machine. So you will lose all your progress, all your well-deserved and highly paid for progress, right? Because you pay for the tokens, for the LLM, and you wait for a long time. You don't want to do that, right? Let's fix it. And for that, let's add our ingredient number 5, which is persistence feature from Koog. So again, we have AI agent somewhere in your code. What you have to add is just install persistence feature, provide a storage, like where to store the checkpoints, and you enable automatic persistency. Like it means that it will save the checkpoints after each atomic step. So what will happen again? You have your strategy, and it will save the exact node, exact place in your algorithm, exact step after doing it, plus the whole state, including the message history and other meta information of your agent. Right? Let me zoom it in and zoom it in even further. Let's imagine that we are right now executing the verify solution step somewhere inside, some like atomic action, like sending LLM request. And our agent crashes for some reason. So what will happen? Koog will checkpoint the exact place in the algorithm, right here inside this subgraph. You cannot do this like with plain Kotlin code, although Koog provides you with a way of writing strategies with just code. But the graph approach allows you to checkpoint the exact state of execution. And also, it will save all the messages, like system messages, tool calls, tool responses, and everything else in the database. So again, what happens after you recover from crash, even on another machine? The same agent will recover exactly where it stopped in the algorithm. You will not lose any progress. So just to sum things up, you install the persistent feature, and you need to just provide the storage. For that, you just implement the storage provider interface. Or if you want to use it like Postgres database, there is the implementation out of the box in Koog. So you connect to the database, and you use Postgres persistent storage provider with this database and specify the table. Then the magic will work out of the box. You don't have to write any code at all. So now let's scale our application. Imagine that we have one user that launched one support agent. And then we have much more users coming to the system. And all of them are launching more agents. Well, anything missing in our system? Look at this glass on the eye of this emoji. We need to monitor and observe the system, right? We need to be on call. If something happens, if the agent doesn't behave correctly, we need to be able to monitor and see what's happening. And that's our sixth ingredient, observability tooling. Let's integrate with that. Same way we just installed persistence to the agent. Let's use the same the dependency injection mechanism. We install OpenTelemetry feature to the same agent. And inside, you can configure it to work with any span exporters, any OpenTelemetry compatible tools that you want. For example, we out of the box provide the integration with Langfuse, which is one of the most popular observability tools. You just use add Langfuse exporter. You provide the URL and credentials. That's it. Then you open your Langfuse console, and you will see all the prompts, tool calls, requests, LLM messages, responses, how many tokens, how much time you spent. And also, you see here, there is a graph. You will see the whole graph of execution of your nested nodes, like in your algorithm. So you can see, observe, and reason about your agents. We also integrate with weights and biases with. It's another popular enterprise-level tool. It provides you similar console. And actually, you're not bound with these solutions. You can use any other OpenTelemetry compatible tooling. It's just an interface. You implement it, and you provide these span exporters wherever you want. And now imagine that you spy on your agent. You observe that something is happening. And you realize that, well, it fucked up. It doesn't behave correctly. It chose the wrong path in the middle. Or it's like spinning in the loop back and forth without making any progress. You start investigating the issue, and you realize that, well, it was just because of some step in the past. So what would you usually do in that situation? You don't want to lose the progress, but you would rather recover to that step, right? And that's pretty easy. Let's add the endpoints that will roll back to a checkpoint back in time. But first, I forgot to add another component, which is connecting Koog and your Spring Boot application. So we provide the out-of-the-box support. We just define what model connections and other things you want to use in your Spring YAML config, like OpenAI key, Anthropic key, maybe some other models, doesn't matter. And then you can define this service that I announced at the beginning. It's something that you would write. It's a Spring service called Koog agent service. You can call it any other name. And it will inject the prompt execution, the executor parameter, which will connect to multiple LLMs, also span exporter, builder parameters, and anything else. So what will component do? First, it will keep a map from a agent ID to the instance of the currently running agent. This is not the production code, by the way. It's just an illustration. So it's just a map. And creating agent is simple. We already done that. It just takes the user ID from request, and it constructs the user tools class. It creates the agent, provides the prompt executor, tools, installs all the features like persistency and anything else. And finally, we save the agent ID to the map. That's it. And launching our agent is also straightforward now. So we create the agent, we run it somewhere in parallel, forget about that, and return the ID to the user. So now, how we define the rollback function? Just a few lines of code. I get the agent ID and checkpoint ID from the user, and I retrieve the running instance of the agent from the map, access the persistence feature, and use rollback to checkpoint. Just provide the checkpoint ID. That's it. And you can do that even in runtime while your agent is still running. So now we can add the promised rollback to checkpoint REST method. So it's going to be a put request. It will get the agent ID and checkpoint ID. It could be like a console of running agents available for the user, or it could be available for you as administrator of the system. Doesn't matter. It's on you. So it will tag the agent ID and checkpoint ID. And how to implement this method? Just call the function that we just defined, agent service.rollback, agent ID, checkpoint ID. You handle the errors. That's it. But what can go wrong? Any ideas? Let's imagine that we are like O3 or any other reasoning model. Let's like reason about what's happening in our system. So we have long-running agent that you can checkpoint back in time to some state. And the agent is essentially applying some tools like chatting with the user, also going to a database and creating and changing some orders. Do you see the problem? Well, infinite loop? No. Side effects. Your tools, they have side effects. Your agent have already ruined the state of the database. If you checkpoint back in time your algorithm, you will not checkpoint back in time your side effects. And by the way, like yesterday evening, I had a nice chat with James Ward. Do you know his book, Effect-Oriented Programming? So we discussed that. And by the way, Koog already applies this principle by design. You have a separation of strategy logic from any side effects like tool calls, LLM requests, and everything else. And that allows you to easily solve this issue. So yeah, you don't have to just roll it back blindly. You have to think about rollbacks as a developer. Of course, it's your responsibility. So the seventh ingredient that we're going to add to solve this issue is called rollback tool registry. Remember, we had the normal tool registry that will register the tools for the agent. And it's going to be like the registering the anti-tools or like rollback tools. So let's do that. We have our persistence feature configuration, which will have the storage, and it enables automatic persistency after each step. Let's add this component, rollback tool registry. So what you have to do as a developer, you have to think how to roll back the side effect of each tool. For example, how to roll back issuing a refund. Let's undo the refund. How to roll back making another order. Let's undo the order. How to roll back if we already contacted the carrier. Let's send another email. Well, sorry, forget about that. How to roll back updating the address. Let's roll back the address. Pretty obvious, right? Checkpoint question. How to roll back creating a user. Yeah, remove the user. Yeah, so it's a developer's responsibility to think about the rollbacks, and the framework will take care of all the state management, and it will apply them automatically whenever you decide to checkpoint back in time. And it will rebuild the states that you had in your database. Works like magic. So, no problems. We solved quite a lot, right? So we made a well-defined, programmed by you resilient strategy. We thought about recovering from crashes. We even thought about side effects and rollbacks. Any other problems? Well, OK, if I'm asking this, of course there are. So at the beginning, or actually in the description of this talk, I promised to share some experience of JetBrains, the problems that we faced and we solved. Here is one of them. When you're actually running your agent, not for a demo, but for actual, like on actual production scale, and the agent is running for a long time, like you can think of coding agent that will generate the code, and it can run for like minutes and hours. Or chat assistant that will have long conversations, right? Essentially, especially if you use, by the way, a small model like Ollama, the message history will grow too long. And the agent, so like what happens under the hood? Each tool call is a message. Each tool reply is a message. Each user request or LM response is a message. All of that gets added up to the back of the history. And in order to make the next decision, what LLM will do? It will read the whole book. It will analyze what's there and give you the next page, right? If you think of this analogy on the picture. The problem here is that, first of all, you will be paying much more money for the input tokens. Second of all, you will spend much more time waiting for the LLM response because it will be like reading all the book. And some like larger models would not break, but they will decrease drastically in quality. We run this like coding agents through the benchmarks, and we checked that. They're like pretty expensive benchmarks to run, by the way. They cost you lots of tokens. And we checked that, and we realized that at some point after a long history, your agent decreases the quality drastically. Some smaller models like Ollama, they would just break if you reach the context limit. So how to solve that? Of course, we have a solution. There is the ingredient number 8, and that's going to be the last one in this talk. The history compression. That's another out-of-the-box component that Koog has, and you can use it. It's called LLM compress history node, this one. So it takes any type. For example, in our example, it could be order update summary, and it does nothing with it. It only changes the underlying state, the underlying message history. So you can just use this component and put it anywhere in your strategy with some conditions. I will show it. But essentially what it does, it reads the history using some LLM and AI algorithm, and it has some fine-tuned prompt. I hate prompt engineering. I don't want you to do prompt engineering. That's not my favorite type of job, but I really appreciate our awesome machine learning engineers who do that. And they already done this work for you. So we checked how it works, and they constructed a fine-tuned prompt that just works. And it will compress the history into a TLDR message, like what is important to continue. And now you can put it anywhere in the strategy, like, for example, after the adjustment state, you will go to compressing the history. If there are too many tokens spent, we'll define what it means later. Otherwise, if it's not too many tokens, we will go to verifying the solution. We just continue the strategy normally. And of course, after compressing the history, we also continue the strategy. All right? Let's define what is too many tokens for us. So for that, we will access the LLM underlying state using the read session, because we are in a parallel environment, right? And we will use the latest token usage from the model. And let's define that if it's greater than some like large threshold, It's not like real number. I just made it up, like 100, 500. If it's greater than some threshold, let's do the history compression. That's how it works. You can play with it by yourself. But now there is another problem. Here it is. Instead of reading the whole book, LLM will be just left with one small message describing what has been done. Now it's not informed enough to make decisions. And of course, we already ran through this problem. We tested multiple different agents with our ML colleagues. And of course, why I'm saying this, there is a solution for that as well. So inside the node history compression, you can also provide a strategy for history compression. Sorry, it's my favorite word. Like really, I love the word strategy. Let's call it together, strategy for history compression. So the one that we're going to use is called chunked history compression. So what it will do, it will like chop the history into pieces of the same size and compress each of them independently. So we are kind of like keeping the same plot of the book, but we are compressing it inside. And we checked that through the benchmark, and it works much better than the previous approach, but not good enough. Why? Remember what I said in the beginning. You should not fully trust LLMs, because you are much smarter than them, right? You are humans. And you know much better than LLMs what kind of problem you are solving. You know what type of information is important for the next step of the strategy. Let me illustrate that. So there is another strategy for history compression. It's called fact retrieval. And that's pretty much some of the most advanced strategies. You don't have to program that. You just use it out of the box. It's called retrieve facts from history. It's available in the framework. What you have to do is you only declare what type of facts will be useful for the next step of execution. For example, that's just an illustration here. So let's say that single fact that answers to the question, what was the initial root cause of the problem? It pretty much will be useful to continue the execution. And also multiple facts, like steps that are not like all the steps of the solution, but what steps were important to solve the problem. Let's also keep that in history. So what will happen under the hood? Again, our amazing ML colleagues, they designed some AI algorithm for that and constructed prompts and extracted the data. And you can also configure that. And I'm not showing it here, but you can pass another parameter called different model. So you can use unbiased LLM to reason about the current LLM's history. And it will essentially extract the facts that you mentioned, the relevant facts, and then construct the new history so that it looks naturally as a conversation, so that the facts, they don't appear from the air, right? And this is, by the way, the piece, like a part of example from our one of iterations of our actual coding agent that we did in JetBrains. So here is the history compression part of it. So we used actually more than 8 concepts that were relevant, and we checked that this approach worked the best for us, for our agent. So if we are solving code generation or any reasoning about code kind of problem, we would need to save the persist the project structure information or any facts relevant to that. Project dependencies retrieved by LLM, or any achieved in progress during the process, and actually much more, like 8 more concepts that our colleagues designed. And that was one of the most best working approaches for us. So it gave us around like 6 or 7% increase on the benchmark. And that's the illustration how it works. So instead of reading the whole book with fact retrieval, LLM will be left with just a few important pieces of paper on the table. That's it. It will work much faster and with much higher quality. So just to sum it up, what we just built a support assistant as a kind of sandwich application. And the first ingredient was actually your Spring app. Then we added AI agents from Koog. We also included the tools, again, from your app. We designed a custom, trustful, and resilient strategy. If it's not resilient enough for you, you can add up more steps. And we thought about recovery from crashes with Koog's persistence feature. Also, we added observability tooling for monitoring your agents. We thought about the side effects and rollbacks. And we also included the history compression to make it working better at scale. All right, so if you want to explore the full example, the full recipe that we just cooked, please feel free to scan this QR code or go to our GitHub with examples. It's in our official GitHub as one of the examples. And you can check out the code. I finished it yesterday, so I hope it compiles. I mean, it does, really. Trust me. And yeah, we actually also recently launched our new, shiny, beautiful, awesome Koog website. Please go to the link jetbrains.com/Koog or scan this QR code. And feel free to check it out. There is like lots of information, documentation, videos, and of course the link to the GitHub, which you can also access here. So try Koog today and cook your AI tomorrow. Please, if you want to, of course, like check out the project, don't forget to add a star or watch. And thank you so much for your attention. So we have 3 more minutes. Do you have any questions?
Is it ready for MCPs?
Yes, we do support MCP. And by the way, the team that is behind Koog framework is also the official supporter of Kotlin MCP SDK. So you can integrate it with MCP, of course.
Nice. A2A both?
Yes, and A2A also, we released Koog 0.5 last week, I think. And it came out with the full A2A SDK. And also it targets multi-platform. So you can use it in Java applications, or you can also target WebAssembly or Android or iOS. And we have the full A2A support for that. Yeah?
For the rollbacks,
Yeah.
in order to implement that, you obviously need to capture some amount of state. So the obvious bits would be like the inputs that went to the effectful code. There's also presumably state, like say if you change the address.
Yeah.
What was the code for change address would be the new address, but the old address
Yeah.
might not be in the arguments of the function. How does that sort of stuff work for gathering the information required to do the rollback?
Yeah, that's a good question. So actually, I haven't shown it during this presentation, but the way you define the rollback tools, opposed to like the normal tools, is that they have to have the same set of arguments. So if some tool like create user has been called with user ID, remove user should also have user ID of the same type as an argument. And that will imply that the Koog framework, because it's effect-aware design, it will have the lock of all the applied tools, and it will reapply them in reverse order using the same arguments, but calling not tools, but kind of reverse tools. So that's how it works. Does it answer your question?
I guess the extra bit would be, so in order to do it, you'd have to be able to, your information has to be stuff that comes through the function.
Yeah.
As argument, any other information that is sort of like data, so as part of implementing the tool, you might get data from the database.
Yeah.
Any other source of data that hasn't come through the functions, you'd have to cater for that separately in order to do the rollback.
Yeah, good question. Right? Let me say it out loud. So yes, if the tool requires, apart from the argument, also the access to some external state of your application, of course, that should be also available to the revert tool. So you have to think about that as a developer, as you normally do. So the thing that framework provides you is a way of applying it seamlessly, and you only define it, like you think of all of that just as functions to be called, and that's it. Yeah. Yeah, the last question.
Yeah, in the observability section, you showed that you can have a look at the history of conversation.
Yeah.
Do you have also some stuff in place to preserve privacy? So to mask out sensitive information, for example?
Yeah, good question. Let me actually go to this slide because there is actually an answer to this question. So there is a second parameter that I set it here. It's called setVerbose_true. This means that it will send all the requests, all the information, even the private data to the tool like Langfuse or WNB or any other tool. But of course, if you don't set it, these tools are designed for enterprises, and of course, they have all the guardrails to exclude this information.
So there's also ways to indicate what information is sensitive.
Yes, and also there is another parameter that I'm not showing here. It's called message filter. So you can filter out the messages that you don't want to be sent elsewhere.
Thanks.
Yeah, thank you so much.